Now let's look at the inverse tangent function. Can the tangent function have an inverse? The answer again is yes, but only if the function is 1 to 1. So is this function 1 to 1? Although we can see that it does pass a vertical line test, right? I draw a vertical line and the graph only goes through one spot. If I reverse that and do a horizontal line test, I see that I cross in multiple spots. So I need to restrict this picture or this graph or this function. I need to restrict its domain. Before I do that, let's take a look at this example, making sure that we understand how the inputs and the outputs reverse. If the tangent of pi over 4 is equal to 1, then what we know is that the tangent inverse of 1 is equal to pi over 4. And so what was an input becomes an output, and what was an output becomes an input. And here's our formal definition. The inverse tangent function, y equals tangent inverse of x, means that x is equal to tangent of y. The inverse tangent function is sometimes called the arctangent function, and it's notated by arctan of x. So y equals tangent inverse of x has a domain of negative infinity to positive infinity, and has a range from negative pi over 2 to pi over 2. And you might recognize this as being similar to the sine function. So why did they pick that restriction? Well, like we saw before, by restricting it from negative pi over 2 to pi over 2, we include positive values and we include negative values. Now notice for the tangent function that we can't include the actual values of pi over 2 and negative pi over 2 because those are vertical asymptotes of the tangent function. That was not the case with the sine curve. So here in our graph in blue is the tangent function over its restricted domain. We have the line y equals x, and if we fold on that line y equals x, we will see the inverse tangent function graphed in red. Example 4. Use a calculator to find the tangent of 13 pi over 7 rounded to 2 decimal places. So using my calculator, the first thing I want to do is make sure that I'm in the right mode. And because the input of a tangent function represents an angle, and because this angle does not have any degree markers on it, I know that I must be in radian. So I'm going to make sure my calculator is in radian mode, and when I put into my calculator tangent of 13 pi over 7, and I take that answer and I round it to 2 decimal places, I got approximately negative 0.48. Part B says, based on your answer in Part A, then what should the tangent inverse be of negative 0.48? Now you'll notice that that negative 0.48 is now an input, where on Part A it was an output. So I would expect this 13 pi over 7 that was an input for Part A is now an output for Part B. Now, what I always recommend is trying this in your calculator, and if I put into my calculator tangent inverse of negative 0.48, I got an answer of negative 0.448. Now I can tell right off the bat that something's not right, because 13 pi over 7 is definitely a positive number, and this is definitely not a positive number. In fact, if I put 13 pi over 7 into my calculator, 13 pi over 7 gives me approximately 5.83. So there is something wrong. What I know is that 13 pi over 7 is not the correct answer. So why not? Well, if you go back to the previous slide, you will remember that for tangent inverse, I can expect an output to be between pi over 2 and negative pi over 2. 13 pi over 7 is going to break through that border, and here's how I know that. One whole rotation around a circle is 2 pi, and 2 pi is the same thing as 14 pi over 7. 14 divided by 7 is 2. So what that tells me is that 13 pi over 7 is just a little bit shy of one full rotation. Now, there's nothing wrong with that answer. I am in the fourth quadrant. However, I did break through that border. So what I want to do is to express that angle or that location in a way that doesn't do that, doesn't break through that border. Well, the reference angle of 13 pi over 7 is 1 pi over 7, because if you take 1 pi over 7 and you add it to 13 pi over 7, that is the distance to the closest x-axis. So if I put a negative on that, I can say that negative pi over 7 gets me to the same location. So I can say that the tangent inverse of negative 0.48 is actually negative 1 pi over 7. And sure enough, if I put into my calculator negative pi, which is 3.14, and I divide it by 7, I will get a response of negative 0.448. So you have to make sure that you're paying attention on tangent inverse or sine inverse or cosine inverse to what the restricted output is to be. Part C says to evaluate tangent inverse of the square root of 3. So I'm looking for the angle that produces a tangent inverse of the square root of 3. Another way to say that is the tangent of some angle is equal to the square root of 3. Now, you may have a chart in your notes that will tell you the answer to this, but if you don't have that chart, then what you have to go off of is the sine of some angle divided by the cosine of some angle equals the square root of 3. So I can tell that it's going to be probably in the first quadrant, because if it was a fourth quadrant answer, I would have a negative sine and I would have a positive cosine, and that would produce a negative square root of 3. Mine is positive, and so I know that I'm in the first quadrant. Let me start with my 30-degree angle, and if I don't have this memorized, I'm just going to have to work this out. Let me erase this work here. So let's see here. The tangent of pi over 6 would be the sine of pi over 6, which is 1/2, and then I would divide that by the square root of 3 over 2, which is the same thing as multiplying it by the reciprocal. That would get me 1 over the square root of 3, which if I rationalize that denominator gets me square root of 3 over 3. That is not what I was looking for. So I'm going to say that pi over 3 must be the correct answer. In fact, tangent inverse of the square root of 3 is equal to pi over 3. And you can double check that on your calculator. Your calculator is probably going to give you a decimal answer, but you can simply take 3.14 and divide it by 3 to confirm that they're the same values. And then finally, the last one, evaluate tangent inverse of negative 1. And like we saw above, we know that we're looking for an angle. So the tangent of what angle produces negative 1? Well, in order for that to happen, I know that the sine of that angle divided by the cosine of that angle must give me negative 1. And negative is only going to happen in this fourth quadrant. And not only that, but the only angle that is going to give me a negative 1 is going to be a multiple of pi over 4. And that's because my outputs are root 2 over 2, comma root 2 over 2. If I'm in the fourth quadrant, of course, this second piece is going to be a negative. So I would expect my answer to be 7 pi over 4. But because 7 pi over 4 would break through that border, I'm going to instead express this as negative pi over 4.